Hi, in this video I'm going to show you how to take a raw photogrammetry scan like this and clean it up into a clean asset like this without all of these extra parts on the base, and we're going to clean up little holes and things like that. And then in part 2 of this pair of videos, I'm going to show you how to turn this cleaned up high resolution scan, still 2 million triangles, into a low poly asset that you can use with a traditional LoD pipeline. And this middle asset you could use, with Nanite, our new rendering technology in UE5 Early Access. And all of this is going to happen in the engine. In the editor, we're going to use our built-in modeling tools to do this cleanup and creating this low poly LoD with baked normal maps. Okay, so let's start. I'm going to get rid of these and we'll start from scratch. First thing you want to do is set up your project. So I'll just show you a few things. First of all, to do all this stuff, you're going to need modeling mode. So modeling mode is experimental in Unreal 5.0 Early Access. And so it's disabled by default, so you have to turn it on. So to do that, you go to Edit Plugins and search, just type up here, Modeling. And turn on Modeling Tools Editor Mode. This is the only plugin you need to turn on. You don't have to turn on any other mesh plugins you might find. If you type mesh in here, there's all sorts of stuff. You don't need any of that, just Modeling Tools Editor Mode. Okay, now the other thing you might want to do is go into your project settings and change a few settings in here. So generally when I'm cleaning up a scan like this, I work in an empty level and I want to just configure my project. You might only do this temporarily, but what we want to do is turn off a few things. In particular, we want to turn off lumen. I'll explain why. We want to turn off global. So if you type global up here and you find global illumination method, it'll be set by default to lumen. We want to set that to none. And then we want to go back up here, type reflections, and reflection method, also set that to none. And then up here, type distance fields and uncheck mesh, generate mesh distance fields. Now you definitely want those things on in your game because that's how you get lumen and awesome rendering. But when we're working with huge meshes and editing them in the editor, this is going to slow things down to have these turned on. When you turn those off, it's going to ask you to restart your project. It's also going to ask you to restart when you enable the modeling mode plugin. So you can do both of those things right now, and then you can go and restart the editor. And now that you've done that, we can start working on this scan that I imported before I started. So this is, you can see, a 2 million triangle. Hopefully you can read it on YouTube. A 2 million triangle scan. That's quite a large model to work with on Unreal. Now with Nanite, you can, use assets like that comfortably. But editing an asset like that is still pretty heavy. That's a lot of triangles in any DCC tool. So I just imported the FBX directly. So these are the files that came out of reality capture. An FBX and a PNG, that's the high resolution scan texture. So I didn't change any of the defaults, which is probably what you would do too when you just import an FBX. In the import settings, there's some options you can change, but I'll show you how to do that afterwards. And then I'll tell you what you could do on import. Because here's what happens when I import this from reality capture, just that raw FBX. First of all, it's super tiny, and if we zoom in, you select it and press F, you see it doesn't look so good. So this is a problem basically with the normals. The normals, Unreal Engine by default automatically recalculated the normals, and because this mesh is so tiny, that normal recalculation failed. So the first thing we're going to do is scale it up. So I'm going to just scale it a lot actually, because I like these things to be quite big when I work on them, because Unreal Engine is made for huge worlds and it's not so good with tiny little stuff. Okay, so I scaled that up. It didn't change anything obviously because I'm just changing the scale on it. The mesh itself is still tiny. So the next thing I'm going to do is I'm going to recompute the normals. Oh, actually no, sorry. The first thing I'm going to do is I'm going to bake this scale in, because working on a scaled up mesh with all these tools does not work very well. It works okay in some cases, but it's really better to work at the true scale. So you want the scale to be 1. But I want it to be big. So the first thing we have to do is bake this scale in. So I went to modeling mode. I've got all sorts of tools over here. What I'm going to do is go to this transform section I run the bake RS tool, that's bake, scale, and rotation. I don't have to change any options. It's going to bake rotation. It's going to bake the scale. I click accept. And this is going to take some time. And the next step we're going to do is we're going to make this faster. So this is going to be quite slow and painful. And this is one of the complications of working with a huge mesh in Unreal Engine with these editing tools, is we need to change some settings on it to make this part faster, because otherwise this video is going to be super boring. And it's done. Okay, now you see that fix the normals. So that is because the scale, no, autosave. Because the scale was so tiny, basically, if you know what floating point error is, the numbers were just too little, and in floating point it couldn't figure out the normals on a lot of those tiny faces. But once you make it bigger, and bake that new size in, it stops being a problem. Okay, but we want to speed up that build process. So the next thing I'm going to do, actually the first thing I'm going to do is make a copy, and I probably should have done that right from the start. It's a good idea to make a copy of your asset. Oh, we should have changed the settings first. This is going to be slow. Oh no, it wasn't slow. Okay, and then just, to have around in case you decide you don't like your changes, because as we're doing these edits, we're changing the asset. So we don't have a source FBX, so we're directly editing the asset in the editor. And if we re-import, it's going to wipe out everything we did. So basically we don't want to re-import from the FBX, and we're not touching that original FBX. Okay, so the next thing I'm going to do is right click and go to edit, RM UV2, that's my static mesh asset. So now I'm in the static mesh editor. And over here on the side, there's lots of settings, and these settings affect a lot of different things, but one of the things they affect is how long that dialog sits up there, which is called the static mesh build process. So, okay, here's our settings. First of all, nanite. Now, nanite's awesome for rendering high resolution stuff, but it takes some time to be built so that rendering is really fast. And when you're doing editing like this, you don't really need that. I mean, you can render 2 million triangles, no problem. So nanite you want to be not enabled. Now, then down here in the LoD 0 build settings, there's lots of settings in here we want to turn off. We want to turn off recompute tangents. We want to turn off remove degenerates. We want to turn off reversed index buffer. We want to turn off generate light map UVs, turn all that stuff off. And we want to turn on use full precision UVs. That's going to be useful for now. You can turn that off later if you want to optimize your low poly, but on this really high poly, you usually want full precision UVs. And you might want high precision tangent basis, that you can experiment with that. And there's one more thing in here we want to change. So we want to change, if you go up in the box here and type collision, we want to change this here, collision complexity, to use simple collision as complex. What that's going to do is disable complex collision for this mesh, because otherwise complex collision will be built for this 2 million triangle mesh, which is quite expensive and takes some time. And then I'm going to clear that, and I'm going to go back up to this build settings, because changing those checkboxes doesn't actually change it. I have to click apply changes. I don't have to click apply changes for the collision settings, but I do for these build settings. So this is also why I disabled lumen and distance fields. So those features also have to be recomputed every time the mesh changes. So you see now that was much faster. So now we can make changes to this mesh, and we only have to wait, a few seconds after the change. So those are things you want to do on this source object. When you're done editing it, you might want to go back and turn some of those things on. If you're going to use nanite on a high poly, some of them don't matter. And on a low poly, you might configure them differently anyway. Okay, so next step is normals. So when we rescaled this up, we got new normals. Those are auto-computed normals. What I want to do is compute normals myself, and I'm going to do that to show you two things. Okay, so when I go into the normals tool, normals here under attributes, I have different options for how I compute the normals down here in split normal. All these things are too small. Split normal method. So per triangle, you see if we zoom in, you get like a normal for each triangle. And on scan meshes, sometimes that kind of looks nice. It kind of gives you some extra detail when you're far away, because this is such a crazy high resolution. Like I forgot to show this before, right? But the level of triangles here is super high because it's 2 million triangle mesh. that kind of looks neat, but if you use that, so let's accept that. So it still does take a couple seconds. All right, like 10, 15 seconds. So now, it looks good, but if I go into this LoD Manager tool, so this is a tool for just kind of inspecting your LoDs. So I already was in here. It starts out with these things collapsed, but the source LoDs, that's your sort of source mesh. That's going to show you like how many raw triangles and vertices there are in the mesh. But then this render LoD, that's what actually goes to the GPU. So you see we have the same number of triangles, but there was 1 million vertices in the source mesh, and there's 6 million vertices in the render mesh. And that's because each triangle has a split normal. And so each triangle gets its own 3 vertices, and that's why it's 6 million from 2 million. So that, Nanite does kind of let you not worry about these things, but eventually you still have to worry about the built asset size when you ship your game. So even on a high-res scan like this, you probably want to use vertex normals. So that was per triangle normals. I'm going to switch this to per vertex, and you see it's going to get softer because now it's all interpolated. There's no more split normals anywhere. And on a high-res scan, that's probably kind of what you want, because usually the scan itself didn't have any hard edges in it. Like the scan data, those are just guessed from sharp angles on certain triangles. So that, and I don't know if you noticed, but it actually built faster. That's because before it had to build 6 million vertices, and now it only had to build 1 million. So if we go back in LoD Manager, it's a little bit more than 1 million. That's because of UV seams. The triangle count's the same. And I'll just show you the UV seams actually, because that's relevant on these models. Something you should know is that there's a ton of UV seams. So now I'm in the inspector tool. I'm going to turn off the wireframe. Boundary edges, this is something else to know. So you see all these red spots. Those are all mesh, those are all little tiny holes. And that's another thing that came in the import process, because when I imported this, there was a remove degenerates option. And that one, the one in this build settings, I can turn on and off, but the import setting deleted those triangles. And so now we have to fix that. And so that's just something to know about. When you import, you probably want to turn that off. But I didn't turn it off because like I said, I just did what you would probably do if you just got an FBX and wanted to bring it in. So boundary edges, if I turn on UV seams, see there's a ton of UV seams. This is kind of common in scan data. And this, can make the mesh hard to work with because of all those seams. But that's part of why we're going to generate a new asset from it. Okay, so we've got our normals recomputed. Next step, I want to get rid of this stuff on the bottom. So, whoops, alt dragged, made a copy. Okay, so we're going to use the plane cut tool under try model. There's this plane cut. And so what that does, it cuts things with a plane. By default, cuts this way. If you hold shift, so you can rotate the plane however you want. If you hold shift, it will rotate at 45 degree increments. So there we go, I flipped it. It does a sort of background compute. So as I move this, you see it's kind of catching up with me. Still a little slow. So what you can do, it's also filling the cut surface there. You can uncheck fill cut hole, and then it'll be reasonably faster. I guess somewhat faster. Okay, and I'm going to bring it down here. The other thing you can do, if sometimes it can be hard to tell exactly where you're cutting, you can check this keep both halves and make this like 5 or something. And then you'll see like a kind of line, and then you get it where you want, and then you turn that off, turn fill hole back on. And I'm going to leave this chunk here so that I can show you how to clean up something else. If you toggle the floor off, you can see it's filling the bottom, and the rest is still there. We're going to accept that. Sometimes the fill doesn't fill if it hit a hole, if it hit one of those tiny holes, and so sometimes you got to jiggle it a little bit. But in this case, we got lucky and didn't hit any of those tiny holes. Okay, So now next up, I want to get rid of this piece. So I'm going to use the Try Cell tool under Try and Model. Let's try Select, Select and Edit Mesh Triangles. So this tool, by default comes on with the wireframe, which on low poly mesh is good, but on a mesh like this, you just want to turn that right off. So this is a kind of a triangle paintbrush tool. It's really fast, even on a high-res mesh like this. And what you can do is paint things and delete them. It doesn't actually have a lot of tools in here, but it's got a few delete. You can split things up into pieces, flip normals. So I want to select this whole chunk over here. The default mode is just this brush, but I'm going to change this to all connected, and then I just have to click once. It's going to select everything over there, and then I'm going to delete it. And now it's gone. Okay, and so that's all I really needed to do in here. I'm going to show you one more thing though, which can be useful just as when you're working on scans. Sometimes there's little floaty bits and stuff like that. So what you can do is just leave it in all connected. If you know your thing is just like one or two pieces, just click on them, select the whole thing, and then go here to Invert. And if you do that, it's going to select everything that isn't part of that main piece. I can't actually tell if there is anything. It might be too tiny to see, but that's kind of the problem. So just do a delete triangles then. I don't know if that did anything, but it only took a second. So now I'm happy. Okay, so now we've got that base filled. And here we go, building. And we got that piece gone. Okay, so now this is not bad, but we know it still has all those tiny holes in it. So we've got another tool here. Autosave. Got to disable autosave. If you want to disable autosave, let's just do it right now so I don't have to deal with it later. You can go into your project settings, type autosave. Oh no, that's not it right. You go to editor preferences, autosave, enable autosave. Autosave could save you, but it's also kind of annoying. So I turn it off. Okay. Right, holes. So the next tool we're going to use is this H-fill or hole fill tool. So what that does is it finds all the holes, those little holes. You see it highlighted them in little red bits. And I can actually go through and click on them to fill them. You see it found 487 holes. I don't want to click on them all, that's a lot. So we have this select all button. So I'm just going to select all. And then it actually has already filled them. It hasn't done anything yet. It's waiting for me to confirm it by clicking accept, but it shows you how many were selected, how many were successfully filled, how many failed, how many holes are left. So it got all of them. So you can also click on holes individually to fill them. This can fill, so these are all tiny holes. It can fill big holes, but I'm just going to mention that when I tried earlier to fill the big hole at the bottom here, it crashed. So apologies in advance, that's a bug that we'll fix. But I believe it's this minimal fill option, and if I had tried one of the other options like planar it, I think it wouldn't have crashed. But just a warning, if you're going to try and fill big holes, save your work. It does work often, but it did crash on this particular file. Okay, so I'm going to accept this. I'm going to wait. And we're done. Okay, so now closed solid model has no holes. That's all good. Ideally, you don't have holes and things like that. One more thing I'm going to show you how to clean up because this scan is really nice. Actually, this was done for me by the Quixel scan team. They're super amazing at this. I have done photogrammetry scans myself. They don't always come out as nice. Sometimes they got extra bits that need to get deleted, and sometimes they have like lumpy parts. This one has this little thing. I think it's probably there on what they scanned, but I want to get rid of that. So what I'm going to do is just use our sculpting tools. So we've got two V-sculpt and D-sculpt. For stuff like this, where you just want to like push the existing vertices around, that's for V-sculpt. D-sculpt, I'll show you in the next video. On a mesh with all those UV seams, D-sculpt doesn't work so good. So what that does is it does dynamic mesh sculpting. You'll have to check the second video and I'll show you. It's pretty awesome. But on this one, I'm just going to smooth. So this, this is our Vertex sculpting, there's a ton of stuff in here. It works really well on a high-res scan like this. Like I can just, go around. Even if I make the brush pretty big, I mean, that looks bad, obviously. I don't actually want to do that. But what I can do is make it really small. I'm going to use smoothing, so you can smooth by just holding down Shift. Right? And now it's just going to smooth that away. The smoothing settings are down here, so I could make the strength higher and it'll smooth even faster. It is going to leave a teeny tiny little kind of lump there. If I go for long enough, it'll smooth it out. If you look at the mesh, it's because there's that little stick had to shrink down into that tiny spot there. So if you've done sculpting, you know about this. If the vertices stay the same, you tend to get those little pinches. But I'm not going to worry about it. So I'm happy with that. I'm just going to accept that, right? So if I was a better artist, I might go through this scan with the sculpting tools. We've got tools like pinch and flatten and stuff. And, maybe I want this to look less busted up, or maybe I want to clean up some of this stuff. So that's there, and you can totally works well on like a 2 million triangle mesh like this. It's very fast. It's got lazy brush. It's got lots of different controls. It's even got custom stamps, so you could add, if you wanted to emboss some details on here, you could do that with custom stamps in the sculpting. But I'm not going to do any of that stuff. So, and this is basically where I'm going to stop with this video. I've got, oh right, there's one more thing I was gonna do before we stop. So, if we change the different lit modes up here, there's like Alt 1, 2, 3, 4, 5. That's how I've been jumping. So it's like wireframe. It looks crazy. Unlit is Alt 3. That's a nice way to just see the texture. Alt 4 is normal lit. Alt 5 is just the lighting, no textures, which can help to see like details so you're not obscured by the textures. And then that's lighting only. Oh right, I was showing you this because of the bottom. So in unlit, you see, so when we did that fill on the bottom, it just got kind of random UVs. It basically just took that fill polygon and it just like made a UV that's already flat, so it could just project it in UV, and then it just got some of this texture map on it. So what I want to do is I want to put a different material down there. So I'm going to make a new material first. I don't know, I'm just going to call it like bottom matte. I guess M bottom, that's the convention. I'm going to double click there. And if you just want to put down a color, you can just hold down 3 and click. I'm going to wire that up to base color. And then I'm just going to set this to, I don't know, I'm not great at colors. Something that's kind of feels like it's in the ballpark of what the rest of this thing looks like. Now I want to assign that to these triangles down here. So I'm going to use a tool called Matte Edit. So this has the same, oops, I had the floor selected. This happens all the time. Let's go back there and let's switch to this unlit mode again. It'll be easier to do this. So I'm going to start the Matte Ed tool. So I was in all connected mode. What I'm going to use here is I'm going to use angle filtered. So what that means is it'll only select things that are like basically flat when it's 1 degree like this. I might want to bump it up a little just so I make sure I get my neighbor triangles. And if you miss some like that, sometimes it'll be hard to hit. There's this button, Optimize Selection. Ooh, okay, because it didn't work. What it does is it selects any like missing triangles, but it also sometimes removes some on the border. It works really well on high-res stuff, but I guess it didn't work so well there. Okay, so I got the base selected, the part that we generated. Yeah, there's a bit more there. You can actually do, no, we don't have expand to angle connected yet. That works though. Okay, I think I got, there's some down there. I think I got most of it. Okay, now the UI is a little bit weird in this tool, but now I want to put this material in here. I can't just drag it on. What I have to do is first of all add it. So I go to this material list and I add a material. I'm going to drag M bottom in there. And now I want to assign that material to these faces. So it's not based on what I've clicked on here. It's based on this number here. So 0 and 1, I have to put 1 here, selected material. Now when I click assign, it's going to, these red faces are going to get that material. So you see now, yeah, I could probably make that better, but I'm going to leave it for now. So now I put the second material there on the base. It's going to build. You can actually do texture painting, a little bit of texture painting on Unreal. You could probably, someone who's good at that kind of stuff could probably paint something blended into the borders. But I'm not going to do that. I'm just going to leave it like this for now. So, I mean, it's on the bottom, it's dark and lit anyway. Okay, so there we go. We went from this, that was where we started. And now we have this cleaned up, fully closed, high poly asset that, you know, we can turn nanite on now. We can come down here and turn on nanite, go nanite, right click on the asset, nanite enable. I'm not going to do it because it takes a while then. And then we can drag, you know, 1 million copies of this and have billions of triangles worth of this statue, if you've seen kind of demos like that on YouTube. But okay, that's the end of part 1, and in part 2 I'm going to make the low poly. So thanks for watching, and check out part 2.